I think you need to enable screen sharing here.
Oh, yeah, sure. Sorry. I forgot it. Yeah, probably you can do that now. Yeah.
All right, cool. So I was just going through this and I understood the stability part.
Yeah.
And when I got to here, the state feedback control. So
Yeah.
I understand the controller of here of the negative k delta x of k.
Yeah. Yeah.
But I guess I was just wondering how this next liner comes about.
Yeah.
Is this just a straight up substitution?
All right, sure. So in this case, you know what is A, right, and what is B.
Yeah.
Right, and then yeah, you just like use the back substitution. Then you get that it's 1 plus like square root of 2. Sorry, I have a like I have a face-to-face. Yeah, have a seat first. All right. Yeah, sure. Thanks. Yeah, it's just like that, but I mean, it must be at the equilibrium point. This is something what I want to say. So it must be at the equilibrium point, and then when it is evaluated at the equilibrium point, then you get the equation first, the second equation, right? That's the second equation.
Yep.
All right, and then if you make delta u, the third equation, if you make the delta u is equal to minus k delta x, right? Then you back substitute the delta u into equation 2. Then you get equation 4. Equation 5.
Okay, I think I see it.
Yeah, so then you get equation 5. Then you choose a proper k to make the new A matrix. The new A matrix is something in the it's 1 plus square root of 2 plus 2k, right? So that's a new A. To make the new A has like eigenvalues between -1 and 1. All right. So in this case, because it's not a matrix, it's a scalar.
Yeah.
Then you just make the number between -1 and 1. Then you make it stable. But the only thing is, if you go following, when you get that, when you get k, then what you need to do is suppose you get like you make a minus k, a minus bk, kb is 1 minus square root of 2, right? And then you get k is minus square root of 2. Then the only thing is after you get k, then you probably get u, right? And after it's delta u, right? Then after you got delta u, you may probably need to get the extra u.
Okay.
Yeah, and then you can put it in the original nonlinear discrete time system. Yeah, I think I have the followings. Yeah.
Okay. Cool.
Yeah. Is that clear?
Yeah, that's clear. I'll try and probably go through it again just on paper so I can make sure that I remember it.
Yeah, sure. Yeah, sure. Oh, good. Yeah. So if you want to stay here to listen, that's fine. If you don't want, I'm recording it. I'm going to upload it after this session. Then then you can have another review on that if you want. So you don't have to stay. Yeah.
I'll probably stay. I'm going to go through some other questions. If I have any questions, I might just like jump in there and ask.
Sure. Oh, good. Yeah. Thanks to them. All right, cool. So any other questions online? Any other questions? And then if no, then so I have like face-to-face visitor. Then I will talk to him. Then you can listen if you want. Yep. Do you have any questions? Example, yeah. I mentioned this. You can consider the quiz 2 as an example, something like that. But I mean, it is 30%, so which means the questions will be much more than quiz 2 before. It's done before, and also if I remember, it's like 2 to 3 questions, and inside that there will be sub questions, something like this. Yeah, and there definitely needs some calculations, and you may need to make your MATLAB or something ready. It's like it's covered everything. I can't say like which session you're going to, but yeah. So it includes more questions definitely because it's 30%, and also there will be like more calculations. Definitely has some calculations and also some short and long answer questions. Yeah, they will be more complicated, I should say, than quiz 2, but I mean similar to the format as quiz 2. Yeah, so that's a good question. So I think I make it totally 2 hours and 40 minutes, including everything. Start from the beginning to the end. It's 2 hours 40 minutes, if I remember correctly. And don't worry, I'm going to send another email before the final exam. But what I mean is the answering the question is 2 hours, but it's including that you've got like photocopy and download, upload, everything, including is 2 hours and 40 minutes. The window is 6 hours, but I want all of you to finish before in the first 2 hours and 40 minutes. Because if someone finished, then they help the other. It's not fair, right? So I'm pushing everyone to finish everything within the first 2 hours and 40 minutes. Yeah. Yeah. And if someone is, I mean, I'm going to have some interviews after that because it's take-home exam. But I mean, there will be more chance for the students who like submit after that, after 12, 40 minutes, then I'll give like interviews on that. Have questions? Okay, all good? Okay, then that's fine. Then you don't have to stay. I'm recording that. Then I will upload it. And then if you want to like have a review on that, then do it. And I have another one tomorrow, so you can call me for further questions. All right, sure. Yeah, sure. Then wait a second. So let me ask. So for the students online, do you currently have a question that you can ask? Then otherwise, then if you don't, then maybe like I will have a separate separate meeting. Then don't worry, I'll stay here. Then if you have questions, just let me know. All right, I'll just mute myself. Okay. Hi, Janice. Thanks for the question. So you're asking if we use MATLAB to show some simulation or graphics, right? So so for the MATLAB, we are not using it for showing any figures, but just for calculations. You will definitely need MATLAB because there are some calculation questions. There are some questions including calculations. Definitely you use MATLAB. And probably you may also need to do some coding as well, a little bit coding as well. But yeah, so but what you said is correct. It's only helping for calculation, and we will not need that to show some graphics. For example, you've done the camera calibration in the quiz 1. We're definitely not doing that, but definitely you will do some calculations and you will use MATLAB to help. And one thing I want to mention is please don't copy and paste code into your answer paper. All right. So the MATLAB is only helping you to do the calculation. You will need to write the necessary process and also progress and also the necessary equations there, and just use MATLAB to help you to do the calculation. Is that clear?
Yep, thank you.
Okay, cool, thanks.
linearize, so once you linearize a nonlinear discrete time system,
Yeah.
in terms of the controllability and the stability, and then the pole placement and LQR,
Yeah.
the process just becomes the exact same as when you do a linear discrete time system.
Yes, exactly the same because you linearize it. But the thing is, it's only at that point, at the equilibrium point.
So it's only at the equilibrium point. Okay.
Yes, you can't like it's a nonlinear system is so complicated. We can't like analyze it anywhere, but we can do something on the equilibrium point. That's why we we find the equilibrium point and linearize it at that point, and also do all the rest of the analysis and works.
Okay. So then at the equilibrium point, the stability will still be if the eigenvalues, if the absolute value of the eigenvalues are less than 1, or less than or equal to 1.
Between -1 and 1, right? Because it's a discrete.
Yeah. All right, cool. And the next question, I'll share my screen real quick. It was with regards to visual servo anger.
Yeah.
So I was just wondering why we calculate the 2D point X and Y to find our error rather than just to get the error in the image plane with U and V.
Right? That's a very good question. That's a very, very good question. I think why they're doing this is a very traditional and classic method. When I first learned that, and when I was a PhD, then I also have the same question. So you asked a very good question. And my understanding is, if we convert the to a small x and y, then it is much easier to link it to the linear and angular velocity. That's my understanding. Yeah. I mean, you ask a very good question. That is my first question in my mind when I first learned the video servering.
Yeah, because it does seem kind of random, right? Like it's just like make this conversion, but it doesn't really say, why do you make the conversion?
It's a 2D point, but it is not a U and V value, right?
Yeah.
It's not that straightforward, but I mean, my understanding is it is easier to link it to the linear and angular velocity. That's my understanding.
Yeah, and that's the linear and angular velocity of the camera, right? To decrease the error.
That's a very good point. So what we calculated are the linear and angular velocity, which is the control of the camera. Then how to convert it into the end effector of the robot? We need to use the end effector, sorry, the hand-eye calibration. So you have a relative close between the camera and end effector, then you can easily like transform the velocities from the camera to the end effector. Yeah.
And is that relating to that that one equation? This AX equals XB equation. Okay.
Yes, that's a hand-eye calibration. Yeah.
All right. Thank you. I think I think that's all my main questions.
Okay. Yeah.
I guess the last question is just as a confirmation with LQR.
Yeah.
So just let me 1 second here.
Don't worry, take your time.
Let me find the question real quick. Yeah, so with LQR, the Q matrix and the R value, they're just guesses, right? They're like kind of guesses to the system.
Yeah, it's a good question. Sometimes we give it as a constant, as what you said is guesses. Sometimes that there is a like prior on that, but I mean, in reality, they are priors or the guesses. Yes.
Okay.
Yeah,
so
they are given.
Is it kind of just like an iterative process then on finding the best values for the best output, or?
Yes, it's iterative. In solving the Ricardo equation, it's not that iterative. But it's getting solving that is getting a proper or optimal K that minimize the performance index.
Okay.
So that's the optimization. That's the objective of the optimization.
Yeah. So that's essentially all defined by the Riccardi equation, then that minimization of K. Yeah.
Yeah, so it's the minimization. So when we formulate, it's a bit long story. So
Yeah,
when
that's
we
all right.
formulate the optimization, we need objective. Let's say like maximizing a value or minimizing a value, right?
Okay.
Then in this case, is minimizing the performance index.
Okay.
That is a function, and then that's a function with respect to Q, R, and K, and then solving that optimization. Then we can somehow like transform it by solving a Riccardi equation.
Okay, I see.
Something like this, right? And then you solve Riccardi equation, you get P, and after you get P, then you get K.
Okay. Yeah. And then K is the optimal gain, no?
Yes, the K is the optimal gain, which minimizes the performance index.
All right. Cool. Awesome. Thank you. Yeah, I guess there were just like some theoretical questions I kind of had in the back of my mind, you know.
Yeah, sure. Don't worry. So I have another session tomorrow, and if you have any questions, you can join tomorrow, or you can send me an email directly before the exam.
Yeah, awesome. Yeah, if I have any more questions, I'll send an email through her. But I think I'm feeling okay. Yeah. So
that's great. Yeah, that's great. My suggestion is you go through all the like lecture notes. You don't have to memorize anything because it's open book, right? But try to remember some key points. For example, if I have a question asking about visual surveying, then you can directly, like very easily to locate where you want to find.
Yeah.
And that's easier for the exam.
Yeah, I've just been trying to go through like a lot of the activities in the lecture notes to refresh my mind on the theory. But yeah.
Sure. You're asking like very good questions. Thanks a lot.
No, thank you for answering. Yeah.
No worries.
Okay.
All right.
Anyway, yeah, thank you.
No worries.
Yeah, thank you. Bye-bye.
All right. See you.